sorunuz varsa sorabilirsiniz. Bir kez daha record'a başladım ben. Umarım 2 record'u yapıyordur. Üst üste gelmiyordur. Tamamdır. Yoksa öncekini kaybetmiş oluruz. Share edelim. Nerede? Şurada. Evet, bir diğer metodumuz second metot. Şimdi Newton'u gördük. Tangent line'larla yaklaştık. Bisection'ı gördük. Intermediate value teoremi kullandı. Second ne yapıyor peki? Second da second line'ları kullanıyor. Yine 2 tane şeyle başlıyoruz. Değerli. x0 ve x1 bize verildi. Şimdi x0'dan verilen fonksiyona, yani root'unu bulmaya istediğim fonksiyona f of x0'ya bakıyorum. F of x bana bakıyorum. Buradan çizdiğim şu line görüyorsunuz. I need to speak English, sorry. So for the second methods, we need to initial values again, x0 and x1. Look at that. I'm looking f of x0, f of x1, and I am drawing a second line between x0 and x1. That I defined between f of x0 and f of x1 is it's called the second line. And now I am checking where the second line is crossing the x-axis. Look at that. It is at x2. Okay. So from x2, I am again checking f of x2. Now I am using x1 and x2, not x0, the previous one. And between x1 and x2, I am defining a second line. Look at that. This line is going like that. And wherever it crosses the x-axis, this is x3. And now I will use x3 and x2. Look at x3, x2. Second line, and this second line crosses at x4. And now I will use x4 and x3. Look at that, x4, x3. I define that one, and it will cross the x-axis at x5. And this is my real root. See, x5 is so close to my real root. And now, this is how I am approaching to my real root, by following the second lines and checking the intersection of the x-axis. Do you understand that? How this is working? Starting with two values, x0, x1. From f of x0 to f of x1, I am drawing the second line. And where this second line is crossing is my new point. And with the new point and the previous point, again, I am defining a new second line. And wherever it crosses the x-axis, this is my new point. And with the previous one, again, I'm defining a second line, and it will go like that. And since this is the equation of a second line, and if I call this one f of x is 0, once I plug the next one, and I will again solve it for x1, and this is how you can do the iteration. This is the iteration for second method. So what is it gonna give to you? You will give to you 0, 0 and 1, and you will find 2. And now you will use 1 and 2, you will get 3. And now you will use 2 and 3, you will get 4. Okay? And this iteration is gonna go like this. With pen and paper, you can do this iteration. For example, for x to the 4 minus 5. This is the f, and I'm trying to find the root of this one, which is, once we make this one equals to 0, x will be 1/4 root of 5. So this is 1.5. So I need to choose 2 points, starting points. Let's choose 1 and 2. Okay? So x0 is 1, x1 is 2, x0 is 1, x1 is 2. So x1 minus x0 over y1 minus y0 times y1 is gonna be subtracted from x1. So I will apply this iteration, and by using that one, f1 is minus 4, f2 is 11, so I will plug them in here. So x2 will be x1, which is 2, minus 2 minus 1, 2 minus 1, and y1 minus y0 which is F2 minus F1 here times F2. Exactly. Now I find X2. Look at that. Now I will use X2 and X1, which is 2, to find X3. Okay. You will do that and you will find X3. And the iteration will go through like that for the second method. And do you understand that one? You will plug it in here, the right-hand side. Starting with 2 values, and the new one is gonna be updated with the xi. And the previous one will be xi minus 1 right now. And this is how we are defining the MATLAB program for the MySecond. Now we are defining a function, 2 values x0 and x1, and how many iterations we should do. And what we need f of x0. This is f of x0. This is f of x1. That's why I'm defining f of x0 and f of x1 as y0 and y1. Because we need y1 minus y0, x1 minus x0 times y1 subtracted from x1. And exactly this is what I'm doing here. x1, I am just putting this formula inside the body of my for loop. And I need to find what is y equals f of x to get the approximate of the new value. And now what is my previous one is now x1, y1. The new one that I found is x1, y1. Okay. So x1, y1 is started x0, y0. The new ones is x1, y1, and it will go the iteration like that. And let me open it. So since I already defined that one in desktop, there, my second is here. This is the written version of my second. And you know how to call it. We need to define our f. Let me call this one here. F is, what did we do? Let's do it the same example. What was it? X to the 4 minus 5. So F is inline X to the 4 minus 5. X0 between 1 and 2 we were checking, right? According to our example here, X0 was 1, X1 was 2. That's why I define 1 and 2 here. And let's do 2 iterations. Why? Because my second is not inside the desktop. Since I'm calling this function from the mat300, that's why I need to change my folder to mat300 because my second function is inside that one. Now it is giving you the answer. And what is the real answer for x to the 4 minus 5? 1.5, right? This is what we said. We already defined in here. Check that. The real root is 1.5. Or you can check it here. It is 5 to the 1/4. It is 1.495. It's going like that. Exactly. This is the real one. And what did we find after 2 iterations? 1.39. So it was not enough. Then let's do more iterations. Instead of 2, let's make it 5 iterations. And as you can see, it is closed in 3 decimals. And if you increase the number of iterations, you can get better results. Where is that? Here you go. This is the real answer, and this is the approximated one, and it's same. After 8 iterations with my second, you can reach your real solution. I hope you can follow me. I know you said that there is some time and video lab. But since the idea is same, I hope you understand that pun. And another method is the regular falsi method. The difference in this one is it's very much like the second method, but it is also using the idea of bisection. So instead of the previous value, it is checking the value that has the different sign like the bisection method. So again, we are starting from x0, x1. This is our second line. Look at that. I find the intersection point with the x. And now I am checking x2, but not with x1. I'm checking it with x0 because it has the negative or opposite sign with x2, the new value. So after each iteration, you need to check the sign of f so that you will update either x1 or x0. For the second, it's always using the previous one. It's using x1. But for that one, it will use x0 because it has the different sign. And now with x2 and x0, it's finding the new value. And now again, it's checking the sign. x3 has negative, but x2 has also negative. That's why it is using x0 still. Now with x3 and x0, it is using the second line. Check the intersection point, still negative. So it will continue to use x0. So this is the difference between the regular falsi and second method. You need to check the sign of the f in each iteration. Okay. And this is just one written example for the regular falsi. So A and B, you are starting. You are checking the signs. These are different signs, so that's good. Now you are using the C according to the same second method, kind of, with that one. And you are looking for the C. Once you find C, now you need to check the sign of f of C. If f of C, let's look at it, it's negative. F of A was negative. That's why you need to use you need to update f of a because it was -1 with 1.1. And now your new interval is not 1, 2, it is 1.12. And you will define a second line between that. You will check the C and whatever the sign. If it is negative, you need to again update 1.1. If it is positive, you need to update 2. And exactly it will go on like that. And you can see that it is very slow to converge. So in here, according to the convergence, I also try to summarize what is the results of these methods. So if we can begin with a good choice of x0, Newton's method will converge to x rapidly. The second method little slower than Newton's method, and the regular falsi method is slightly slower than that. However, both are still much faster than the bisection method. So bisection is the slowest, we can say that. But if you don't have a good starting point, then the second method, just like the Newton's method, can fail. Regular falsi method, just like the bisection method, always works because you are already defining, you are making sure that there is a root between them. But for secant and Newton, you are not sure if there is a root between, because you are not checking the signs of the functions, right? That's why regular falsi and bisection works for sure, but they can work slower. And you can do this by checking. I give some reviews in here. These were the nice reviews what we did according to the methods. You can check that. And also I want to show you the homework due 1st of November, midnight. So in the first question, you need to find the table of data. Make sure that you indicate what the data is and where it came from. Make sure that you do all those steps so that you can get full credit. Because I will be checking if you put it as vectors and if you plot it. I will check if you use insert icon to, not icon. You use labels, not, let me say not use. You should label. I don't want you to use insert icon. I want you to label the axis. Okay, that's the important point. And you should indicate what the data is, and you should include your name and number to your graph as a title. Okay, in the first question. In the second question, you need to define your function and you need to plot it in 3 different ways in the same plot, and you need to compare them. What is the difference between if you use x1, x2, and x3? You will see it once you plot it. And I want you to compute the first 6 terms of Taylor series for tangent x and cosine x. And I want you to graph these. Okay. And also, this is the fourth question. You need to perform 3 iterations for this Newton iterations, and also not just Newton, bisection, secant, and regular falsi. You need to do it with hand, okay? But you can compare with our, program results and put the results in one table. And you can compare how fast they converge to real roots, which one is fastest. Okay? These are 5 questions. You have 2 weeks to finalize these 5 questions. Make sure that start right now. You can ask me if there is any point was not clear for you. And I think that's it for today. Do you have a question? No question?
Thank you, hocam.
Okay, it seems you are also kind of tired. Ödevi MATLAB dosyası mı olarak göndereceğiz? Hayır, Faize bütün soruları bir Word'e koyacaksınız. Bütün cevapları da, yani mesela MATLAB'e yazacaksınız. MATLAB'de eğer MATLAB varsa, orada var mı MATLAB? Var tabii, plotting var. MATLAB'de yazdığınız bütün şeyleri oraya copy paste yapın. Bir tane Word dosyasına. Çıkan sonuçların da isterseniz resmini çekin, isterseniz figür olarak kaydedip onu ekleyebilirsiniz Word'e. Yani ben sizden tek bir Word dosyası istiyorum ödev sonucu olarak. Bütün Word dosyasına el yazılarınızı, MATLAB file'ları, sonuçları, comment'leri, ne yazdığınızı hepsini oraya koyun. Tamam? Tek bir Word file. Tamamdır. Var mı başka soru? Hatice, galiba düzenleme yapılmış. Senin programında şu an normal görünüyor olması lazım. Hatice Fidan. Eğer duyuyorsan beni. Şu an bakabilirsin sistemine. Düzelmiş olması lazım. Tamamdır. Görüşürüz o zaman haftaya. Ben size yine mail göndereceğim. Hem ödevle ilgili, tek file'la ilgili, hem de bir hafta ileriye aldığımızla ilgili sınavı. Tamam. Hoşça kalın.